Hello guys, so today we will be solving these two problems, balanced binary tree and diameter of a binary tree. I think these problems are very similar to which we can actually build their intuition together, but I'll be doing them separately because I think there are some differences that we need to understand, and also because LeetCode does not explain these very well, because this is very bad explanation of what it wants us to do. So let's start with balanced binary tree. We just want to make sure that the tree is balanced. So the idea of balanced tree is basically any local root. Let's say this is a local root. Local roots are basically any node, which is basically the highest point, which is the parent point, only parent point, if that makes sense. For anything, we just want to make sure that its left and right are balanced to the point that the differences are as okay. So the difference should be less than or equal to 1. So it should be either same or it should be basically difference of 1. So this would be balanced. But something like this is not balanced. Okay, I hope that makes sense because this has left as 2 and right as 0, and 2 minus 0 is basically 2, which is greater than 1. So this is not a balanced tree. So let's start with the problem. Okay, so I think there are multiple ways to do this. We can also do this with pre-order or breadth first search, but I will be using post-order DFS just to explain the idea. So the idea is basically we want to start bottom up. So we want to start from the lowest possible node, and we want to make sure that this has something along the lines of a balanced structure by itself. And then we can pass these values to the parent, and then we can keep comparing these with its right, and then we can keep building up, and if we find a false value at any point we can just return false. Okay, I hope this makes sense. Now let's start with the trial of the code. Okay, so just to ensure what I'm trying to say makes sense, I'll actually take this first. This will be the problem we can do on. I can just shift this. Okay, let's do control. Okay, yeah. So here what we can do is we can start here. We start, let's say here from post order because post order is left, right, and then root. Okay, so this would be something like 9. Then line will have null and null. So the difference is not greater than 1. So this is balanced. Now we keep on going. So here we go. And when we go from stack call from here to here and then process left, then it's right. So we come here, then we process left for here recursively. Now when we are here, basically, we will see that this is also balanced because it's left and right are zeros. Now this is fine. So basically, now when we come here, we go to this stack call and then we process this. This is also balanced. So this will return 1, this will also return 1, this will also return 1, and this will now return 2. So now this is balanced because this has 2 maximum, this has 1 maximum, and 2 minus 1 is 1, which is not greater than 1, right? So let's start with another example. Okay, yeah. Here we have left as this will be balanced. It will increase the height. This will receive 1. This will also receive 1. Now here this will receive 2 because the maximum height is either this 2 or this 2. It doesn't matter. This will receive 1. And for this one we will receive this as 3 because we keep increasing by 1. So this will be 3 and this will be 1, and the maximum is 3 minus 1. The maximum left minus maximum right is 3 minus 1, which is basically 2, which is greater than 1. So we return false. Okay, so my idea is basically we go to the leftmost point and at each point from root we go to the leftmost point and then we start a post order. Now what I'm doing here is yeah, I'm passing a flag which will basically indicate if we found something to not be true and then return this. So initially this will be passed as true. Now we'll pass it by reference because, well, we want to make sure that these are the same values getting passed. If cur is equal to null, so basically we want to make sure that whenever we hit a null on iteration, we reset the height to 0. Basically this has nothing below it, null has nothing below it, so height is 0. And yeah, left height and right height for each node. So we start at each node, we are asking, can we go more left, more left, more left? And at some point to the leftmost point, we'll reach this line and then the recursion starts. So for 4, we'll pass the left height as 0 and right and the right height will still be waiting for this to exit. So the flag will be passed and the current height will be returned as 1 because we hit null when we go left of 4. For this one specifically, we will be going towards the right side of this and we will also receive 0. So this will be 0, maximum of 0 plus 1. So now we are here. For this one, since we already executed this to hit this point, we will be hitting this line now, the right one. Now we'll see for right. We also find that this has a maximum height of 1 and we'll return 1. So we have 1 comma 1 here. Now for this, we will pass on the value of 2 for this value, height of maximum left height, right height. Left height is 1. This is also 1. So we return 1 plus 1, which is 2. So for here, we have maximum value of 2. And for this one, we have maximum value of, well, we'll calculate that. So this will be 0, comma 0 and plus 1. And this will be basically 2, comma 1. So maximum here will be 3 because we increase by 1 for each route that we hit on post order traversal. Now we have this and now this write will get executed, and when the write get executed we'll find we only have 1 again, and then we'll return 3 comma 1, which is basically 3 minus 1, which is false because it strictly wants this, never differs. So yeah, this is the basic idea for this. I think the problem is explained very badly. I think we need more proper explanations for easy problems. Now for the next problem, I think this one is a very good problem. Okay, for next one we can do is, okay, so we want to find diameter of the tree. I think this does not explain what a diameter is. So basically what we want to make sure is not the width, which is like the maximum width we can from spanning, because that will not always be the best answer. I'll just show it here. Let's reset all this. Yeah. Okay, for this example, let's see what our possible this is. Now again, the idea here is same. We want to find the maximum length of these. Let's say these are weighted. So we want to maximize these ones from any two nodes. We want to find the maximum distance we can do. This is the diameter of the tree. This is the problem. And yeah, we can solve this like this. So now what we want to make sure is we start with any point and we want to make sure what we can find maximum from there will be the answer that we will supply to the next moving upwards next node, or to the left one, sorry, right one, for the post order traversal. Okay, so for this one, I think this should be a medium rated problem, by the way, because it's not properly defined, and also because there are possibly other ways to do these, but like they require some sort of intuition which doesn't fall in easy category. But okay, anyways, let's start here. So when we start here, we will start with a post order traversal. Now when we start a post order traversal, what happens here is we find that the minimum height here we can do is 0. So basically this gives 0, this gives, now the logic is pretty similar, by the way. I'm just using a priority queue to just make sure that we get the top value as the maximum value because we want the maximum answer. but you can also store a maximum, something called maximum limit, and we can just continue that route. But anyways, yeah. So this will store 1 now because the height has increased, because this is the height, let's say, for each node connection, right? So this is 1 now. Okay, this is 1 now. Okay, for this one, now we'll see what are the possible maximums. So for here, we'll see left is 0 already because we did post order traversal. So we already checked this was 0, then we started here, right? So this gave us 1. So the best thing we can do from here is 1. Now, because it's post order, so we will go left then right because this is the main route. So for here, let's go to this tree. This is the leftmost one. Now here we can see this is also 0. This will give it 1. This will give it 2. And now we go here. This will give this 1. This will give this. Okay, I think I should change the color. I'll change the color actually. Okay. Mm, yeah. So this is 1. This is 1. So we get 1, 2. This will give us 2. And this will also give us 2. Now what we want to do is we want to insert this local maximum into a priority queue. Let's maintain a priority queue, let's say. Now this will get 4 here somewhere. Let's say this is the top for now, right? Okay, since we hit 4, now what we want to do is we can insert every value, by the way. It doesn't matter because we want to find maximum. So let's say we also inserted these zeros and ones and twos. Anyways, it doesn't matter because the best now we've seen as 4. And yeah, this 4 is getting stored here. Okay. Now, when we pass these, the thing is we cannot revisit them. So these cannot be visited, right? So we'll just use the maximum of these two to be used by other nodes. So while we store 4 for this local cost, we'll also make sure that we are only passing one of these values instead of the sum. So maximum of 2 comma 2 is 2. So let's just say we are just using 2 for the other calculations that we do outside this. Now for that, we have this as 6. For 6, we'll see this is 2. It doesn't have any left child, so that will be 0. And then this height will be increased. So this is 3 comma 0. Maximum of 3 comma 0 is 3. So this is 3. Now for this one, this is the root. So before hitting the root, we'll do post order once again here. So this starts as 0. This is now 1. This is 2. This is 3. Now these both are 3 and these here will become 4 and this will also become 4. Now we'll also store the sum 4 plus 4 which is 8 and then we'll use the maximum of these to be used by other values. So because we cannot revisit, by the way, just to clarify, let's say we wanted to maximize revisit nodes. So we could do something like exploring all the paths, but diameter basically ensures that we are not visiting any of these again. So if this had another one, this would be a better one. And we would still store that we can do 1, 2, 3, 4, 5 for this one. But still the outside nodes could give us better results, which would use only this. Because if we wanted to use these two, then we'd have to iterate back to this point, which is not allowed. Just to clarify this, by the way. Okay, so now this is 4. This is 4. So we pass this as 8 here. Now we had 1 here. We have 4 here for any one, maximum of 4 comma 4. So we can choose any one of these. Now this will become 2 because the height increases. This will become 5. Okay, 2 comma 5. So we can basically do 2 plus 5 here. So basically this is 7. 7 will get inserted somewhere here. Now let's see actually how this 7 can be formed. So we can do 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. Right? This will be 7. These all will give us 7, by the way. But now we know there is an 8 possibility, and I think we should already be seeing where it was possible. We saw that 8 was formed here. So let's just greedily find the best one. Now we can choose any of these. So we can do 1, 2. No, I'll just highlight the blue, this one with blue color actually. Yeah. This is 1, 2, 3, 4, 5, 6, 7, and 8. This is the best we can do. Which does not, by the way, this is the main thing, by the way. Okay, may or may not pass through the global route, which is basically this route. So this does pass through this local route because we will be needing a local route, but it does not necessarily need to pass through the global route. Okay, I hope this makes sense. So yeah, these are the problems. For this one also, the code was very similar. It was pretty much the same thing. We basically have a maximum height that we'll pass and a priority queue by reference. Okay. While if current is null, basically we want to return that it cannot add anything. No, none of these things can be added. None of the path values can be added. So we'll return as 0. And then we have left and right best for each node, and basically from there we can say how much depth we can take to increase the diameter, and then we can push each of these values. So because this is always going to be 0 or positive, obviously this will include better than these or similar as these if either of these are 1, and then we keep increasing the height. Basically that is the only code. Yeah, thank you guys.